All right, so let's take a look at a problem. Let's say instead of a drop kind of problem, let's say you're driving along in the car, right? So you're driving along in the car at like 5 meters per second. So you're like in a kind of slow, just turned a corner kind of thing. Let's say you accelerate at a pretty rapid rate. Now, when we really start looking at accelerations, a lot of times we look at those through forces and how much force is your engine going to apply and how much inertia does the car have and that kind of stuff. But right now we could just like relate it to gravity. So, is your car able to accelerate at the same rate that gravity is, right? Can you accelerate your car as fast as somebody's as fast as somebody's accelerating when they fall out of a plane? That'd be quite a bit of acceleration. So let's say we've got half of that, right? Well, I don't want to put 2 5s in there, so we'll do 6. You hit the gas pretty good, so that gives you 6 meters per second squared. And let's say we do that for 10 seconds, right? We're just going to pick a time. We do that for 10 seconds, not 10 meters, 10 seconds. What we could find with this equation is then how far have we gone in that time. This equation wouldn't tell us how fast we're going at the end of that 10 seconds. That would be a different equation we'd need for that because there's no final velocity in here. But this would tell us how fast or how far we've gone in that time. So now I'll rewrite my equation. X equals 5 meters per second times 10 seconds, right? This is the how far did we go just because of our initial velocity stuff. If we hadn't been accelerating, how far would we have gone, right? And then also we have this 6 meters per second squared times 10 seconds squared. As I think about this one, I always like to, as I write stuff, pause for a second and say, okay, how's my directions? Well, they said our initial velocity was 5 meters per second, and then we hit the gas and are accelerating in the same direction. If it had been hitting the brakes, these would need to be opposite signs, right? A positive 5 and a negative 6 meters per second squared. So since I've got this, we can say our x equals 50 meters for this part. My seconds cancel out, plus 1/2 of 6, so that's 3, times 10 squared. 10 squared is 100. 3 times 100 would be 300. Meters, right? My seconds are squared, and so those cancel out with my seconds squared right there. So we're going to cover 350 meters. So you can see because we had a longer time, the acceleration part of it became the more important thing for how much ground we covered than our initial velocity was. If we had started this from stopped instead, we would have still almost covered as much ground, right? We would have covered 300 instead of 350.